So this is Dr. San Abdullah with the course Data Structures, Algorithms and Generic Programming. So the topic which we are covering in this video is generic programming and the subtopic is basics. So this is lecture 2A. So this course is based upon with a supplemental website which is www.easymcq.com/goget. So easymcq.com is a learning management system and these are some of the wonderful features in that learning management system. And to know about them, there are 6 videos which are also available at the course website. I would suggest and advise you to look at them. So this is the outline of the course. As you can see, we have 10 topics, and right now we are at the topic of generic programming. So let's now move on to the tool itself. So we are at the learning management system, and as you can see, there are quite a few courses here. Core computer science courses also, cutting edge courses, hot courses, natural language processing, artificial intelligence, machine learning, and so on. So let's move to the course of our interest, which is data structures and algorithms. And here is a table of contents of the course, and we have general overview which has already been covered, and now we have to generic programming. So we can either go straight into all of the Q&A or we can go topic by topic. So let's adopt both the approaches. So we move on to the generic programming first. So what are iterators and const iterators? So this is the question, and it's a difficulty level, and there are 23 questions, and we are looking at first 5 questions, which is 21.74% of the entire stuff. And this has a reading time of 1 minute and 55 seconds. So we click on and we see the bullets. So we have the iterators, and what is the purpose of the iterators is to go through the data structure and read the contents, and then the key points about the iterators, their purpose, types, and syntax. So this page number is the page number with reference to the text which is going to be shown when I further go down into this drop down menu. So then is the const iterators and the key points about them. So let's look at the description of the answer. So what do the iterators do? Let me use the highlighter. They allow to traverse through the elements of a container. And what is a container? Like an arrays, vectors, list, etc. And that traversal is in a sequential manner, one after the other, one after the other. And of course, that is fundamental part of C++ standard library because we need to be able to read through the container. So what is the key points about iterators? That they provide a common interface, okay, for different types of containers. So the interface is common, it doesn't vary across the containers. And their types of operators are we have input iterators, we have output iterators, forward iterators, bidirectional iterators, random access iterators, very, very powerful because that give order one access time. This is the syntax of the operators. So let me clean this and we move ahead. So examples of using the iterators, okay. So examples are from page 65 to 66. So these const operators allow to have constant content. So we can use this operator to read the elements of a container, but cannot modify the elements through the const iterating. Okay. So to ensure that the elements are iterated, but they are not changed. Changing is not the way to go. So we have these const iterators key points to provide read-only access that we already discussed, and declared using, this is how the declaration is done because this is for the programming part. And let's look at the example of using a const iterator. Okay, let me activate the highlighter. Okay, so the example is for example, CIT is a const iterator for the vector. Okay, vector container, and it iterates through the elements of the vector. Okay, without modification, without allowing modification. So different between iterators and const iterators. Regular iterators allow both reading and writing or modifying. Const iterators only allow reading. Regular iterators are declared using the iterator type, okay, while const iterators are declared using the const iterator type. And then there are use cases of regular iterators and so on. So this is the reference I was referring to. So this is the reference text. The page numbers are from this reference. So what is the purpose of C++ keyword explicit? Okay. So because this is not we are not going to go through all the details. Just I am just touching upon the key things. So what is the purpose of prevent implicit conversions? So we would like to keep the things in our control. And of course, because of this, there is less ambiguity in the code. So that enhances the code clarity. And of course, I'll give you the explanation. So I click on this button, which has now appeared, to look at the description. Okay. So the to prevent implicit conversions. Implicit means kind of indirect. Okay, so it means that ensure that the constructors and conversion operators are only called when explicitly intended. Okay, so this prevents unintended type conversions because that can create a lot of problems, and that can lead to bugs. Okay, or unclear code, unmaintainable code, a lot of wastage of time also, so to say. So the purpose of explicit is prevent implicit conversions. Okay, by making single argument constructor or conversion operator explicit, so prevent automatic type conversion. We would like to keep the control in the programmer's hand. Okay, and it makes the code easier to read, right, and understand. Why? Because the conversions are explicit. And why? Because it reduces the chances of errors, right? And then is the example of explicit. Okay, for example, we say in the example, my class has a constructor that takes an integer. Okay, this is marked as explicit. Okay, let me clear this so that we can move ahead. All right. Okay. So here's the marker you have. So this constructor marked as explicit. Okay, which means that you cannot use indirectly to create my class without explicitly constructing it. That's the benefit. So that this line is commented out because it would cause a compilation error, right? Because this compiler cannot implicitly convert, right, for this. So by using explicit, we can help prevent the unintended behaviors. Okay, so that will make the intentions clear in the code to the compiler and also to the subsequent requirement of maintaining the code. So let me zoom here. Okay, so you can see that which is going to work and which is not going to work. Okay, this will cause an error. Okay, and this is going to work. So this is the advantage of using the explicit. All right, so let's further clarify it. So what is the difference between explicit, square, right, uh okay, and only the square? So this is with explicit and this is without explicit. So let's see how they behave. So without explicit, we have the constructor and we have the implicit conversion, kind of indirect. With the keyword of with explicit, we have the constructor as before, but there are no implicit conversion. So what's going to happen? Okay, so the difference is clarified as per the breakdown as follows. With the constructor, this regular constructor for the square class initializes the member variable side. Okay, with the value of s, right? And implicit conversions, if you pass a double value to a function expecting a square object, the compiler will automatically convert double into a square using this constructor. But when we use explicit, okay, so there is some similarity, but it is marked as explicit. So there are no implicit conversions because of this use of this keyword explicit from double to a square. This means you must explicitly create a square object. You have to do it yourself. Okay. So that does not leaving things to the compiler. So these are the messages I was referring to. So we move ahead, and this is the reference basically. So what is the purpose of predicate in C++? And also give example. So the purpose of predicate we will briefly look at, and it is used for condition checking. It has a custom behavior, sorry, and it improves the readability. So let's look at some examples, and we look at the description of this question number 4. All right. So what is the purpose of C++ for the predicate? So this is a function or function object that returns a boolean value, true or false boolean value it returns. So if, for example, if I have to make a decision in the code and it requires a boolean value, then I will use predicate. So it is for condition checking, allows the algorithm to check conditions on elements in a collection, so making them flexible and reusable. It has a custom behavior also. We can have custom predicates also, to tailor to standard algorithms to fit specific needs without altering the structure. Readability. This can enhance readability because it is clearly indicating the conditions being checked. The compiler can do it, but first of all, it's the human who should be able to do it. So examples of a predicate in C++ standard library: predicate function, if this even function checks if a number is even and returns true or false depending upon the number is even or odd. And we have this count if also, okay, which can takes a range, sorry about this watermark, takes a range and predicate. counts how many elements in the numbers vectors satisfy the condition defined by is even, and then it gives the corresponding output also. So here's the code, and it tells you that whether it's even number of even numbers and so on. So this is the reference. Okay. So what is the purpose of containers in C++? What is the purpose of containers in C++? Containers, they organize the data. Okay, they organize the data, and they organize the data in a certain way that supports certain operations, which maximizes the utility of data usage and efficiency. Efficiency is here, and they provide a level of abstraction. So we'll cover abstraction in a lot of details. Basically, abstraction is at a high level presentation, okay, of something which encapsulate the data and the data structure, and it gives an interface through which you communicate. You as a program, the parts of the program communicate with the data itself. So here there's a lot of flexibility because we can change the underlying data structure without affecting how the interface without having any changes in the interface. Okay, and that is standardized also. So let's look at it. So the purpose is organizing the data. Okay, the purpose organizing data logically. So when the data is organized logically, then it is easier to manage and it is easier to manipulate also, right? The data is not kind of dumped, so it's fairly organized, and it helps to optimize the performance. Performance is optimized. You have efficient algorithms, okay, and for what doing, for accessing the data, inserting data, deleting the data, searching for the data, and so on. There are many operations. There can be many operations. Abstractions, abstract away the complexity of data management, data storage. So the developers, they focus on the higher level logic, instead of going to the low level memory management that is already implemented. And there are various types of containers, and you can use or choose the most appropriate structure. Why? Because of the specific use case. Okay, why? Because you need fast access to do what? For insertion or ordered storage. So you can do many things. So they are standard containers or standardized containers. There's standardization on well tested and optimized implements. So you don't have to implement something or optimize it or test it, because that has already been implemented. It has already been tested. The implementation is optimized, and what it does is improves the reliability of the code and the portability of the code. So there are many benefits. So if you want to, so let me first clean this. And as is shown in the video, we have opened these questions and their answers. So if you want to close everything, you just go to the top and click on close all, and you can only now see the questions. So let's now move on to the next set of questions and answers. So what are the different types of containers in C++? So we have sequence containers, which maintain the order of the elements, and we have associative containers. So the elements are stored in a sorted order. Okay, sorted order based on the keys. So what is the benefit is that allows fast retrieval, because we can do a binary search on them. If they're not sorted, then of course that takes linear time. Binary search takes order log n time. And unordered associative containers, there's no particular order. Okay, it's average constant time complexity, and it is of course if it could be like linear, as I already mentioned. And we have container adapters, so provide a different interface to existing container types. So let's look at the description of, let me clear this and look at the description of the answer. Okay, and let me turn on the highlighter. So we have the sequence containers like a vector, okay, can resize itself, and of course, efficient random access order one time, which we will cover in the corresponding topic in this course. And we have double-ended queue, so we have that allows fast insertion and deletion at both ends. And doubly linked list, which allows efficient insertion and deletions but slower than random access, significantly slower. And we have associative containers, this in a sorted order based on the key values. For example, for a set collection of unique keys sorted automatically, set is unique. And then we have a map, which is a key value pairs. So we have the key which points to the data and the data itself, where it's located. It can vary from book to book. And we have multi-set, similar to set but allows duplicate keys. Okay, set is unique keys. Okay, the set is unique keys, or it allows duplicate keys. So one should be aware of all the containers to make most use of them. And then we have the unordered associative containers, collection of unique keys not sorted. Okay, because there's a cost of maintaining the sorted order, and of course there are benefits of having a sorted order. And unordered map, collection of key value pairs which are unique and not sorted. So these are all they are unordered. So then there are container adapters. Okay, they provide a different interface. For example, a stack. We'll be covering a stack a lot. There's a topic of stack, queues, and list. A queue. So first in and last in, first out, first in, first out. And a priority queue provides a way to access the largest element quickly. It could be largest, it could be smallest. Okay, an analogy could be, for example, you go to a bank or it is traffic signal, and the vehicles are standing and they're parked kind of standing on the road. So when the light opens, the first one is the one which moves out the first. But if there's an ambulance or something, that ambulance has a priority. Okay, so that crosses them. So that's the priority queue. We'll cover this in the corresponding topic. So this is the reference, all right. So what is meant by C++ container? Providing different interfaces to existing container type. So kind of a long sentence. So this is basically the encapsulation of the behavior. So we are not really concerned what goes inside, and that provides ease of coding because the interface is simplified. It's very flexible because we are not concerned about the inside contents. And then there are the common adapters. So let's look into more detail, and let me turn on the highlighter also. So these are the vectors. So we have these. We have the adapters. Let me close this first. Okay, start from here. So, for example, container adapters, these adapters modify or enhance the interface of standard containers. Standard containers are vector and list to provide specific behaviors or functionalities without altering the underlying data structure itself. That is not altered, that remains the same. So, encapsulation behavior, for example, we have a stack provides a last in, first out, and the queue provides a first in, and so on. So, there are different ways to access and manipulate the data. Different ways to access it. And of course, you as a programmer, when you know all of this, okay, that add values to your skills. Okay, and machines have a difficult time, right, to figuring out which data structure to use, which operators to use, why to use them, what are the benefits, and so on. So the adapters provide a simpler or more focused, it's a simpler or more focused interface tailored for specific use cases. For example, priority queue allows access to the highest or lowest priority element quickly. Abstracting it hides the complexity of the maintaining the underlying order, which could be a heap also, which we'll cover in this course. Flexibility: by using adapters, developers can switch the underlying container without changing the code. This is wonderful. Without changing the code itself, that interacts with the adapter. For example, you can change the stack to use a vector or a DQ. Okay, depending upon the scenario. Okay, depending upon the requirements. Okay, depending upon the use case. So what are the common adapters? Stack, queue, and priority queue is just the reference. Okay, so now let's go into some details in the code itself. So give an example and briefly explain that shows C++ container, providing different interface to existing container types. Okay, so let's look at the basic usage, and then we add the elements for a last in, first out, and a first in, first out. Okay, let's look at it. The code. So the code demonstrates the stack and the queue in C++. Okay, it shows how to add elements. It shows how to add elements to the containers, access their top front elements, top in the case of a stack, front in the case of a queue, and remove the elements, so which is like pop in the case of a stack, and dequeue for a queue. So the stack follows the last in, first out behavior, while the queue follows the first in, first out behavior. So let me zoom here. Okay, let me first need to clean this. Okay, so now I can zoom here. Okay, and you can see that how they have been declared and how they are gonna be used. So we have, for a stack we have the push, okay, and we have the pop operations, and we have the for the queue we have the corresponding operations. Okay, so this is how it works. This is the code here for C++, and this is the code for standard for the queue. This is for the stack. All right, so let's move on. So give an example, example C++ code for vector container to store integers and explain the code. Oh, this is very nice. So the benefit of vectors is the dynamic nature. Okay, so these are the points, including the headers, the main function, how we declare a vector, how we add elements to the vector and modify the element and so on. So let's look at this code and the explanation also. So we have the headers first of all, and this includes the necessary headers for IO operations. Then we have the main. Then we declare the vector, okay, and we this is a vector named numbers, right? That is declared, and which stores integers. There's the integers, and automatically manage memory. This is the beauty of it, and can dynamically resize, which array cannot do. And add elements to the vector. So we push and we pushing these numbers into the vectors, which are integers 10, 20, and 30, and then we access them to print them, and we modify them. So at the first location we will place 25, and before that I believe it was 10, and modify the element that we have done, print the modified value, and of course return. So if I can zoom it, you can see it. So here we are pushing into the vector, and then we are performing accessing the elements by their index, and then we modify it, change the first value to 25, and then we print them. So this is wonderful thing which is with the vectors. And what is the time complexity of vector class clear? Time complexity, and we also look at the space complexity. So memory management and pointer resetting. So let's take a look at it. So this is the clear method which we used in C++. And when you call the clear, the vector will deallocate the memory. It will make it available. Okay. Which how it happens, which involves calling the destructor. Okay. And it resets the pointer. This reset operation is constant time O1. Constant time means that this resetting is independent of the size of the vector. And I will discuss it in the corresponding section. Implementation variability. So it can vary between programming languages and libraries. For C++, this is the way it goes, and it may shrink the vector capability, capacity, and so on. So this is how it works, and this is with the corresponding reference. So this is all for the basic part of generic programming. Thank you very much.